Welcome back, everyone. Welcome back to our room after lunch break. Welcome after the lightning talks. As you can see, our speakers can't wait to start. So again, we have our speaker ready on the stage. So quick introductions. You know who he is. It's Patryk Wychowaniec, and Patryk is a senior Rust engineer at Fudo Security, fan of Rust, Nix, Emacs, free software, and dogs. The more the better, exponentially. He likes to throw algorithm at problems, play softball, and complain on the internet every once in a while. Fun fact about Patryk is that he can move his fifth toe, but only on his right foot. Looking at you, deciding who just tried to do that. All right. Please remember to use the conference app to rate our speeches, help us improve. And without further ado, in the speech entitled Kartoffels, emulating thousands of RISC-V CPUs for fun, Patryk Wychowaniec.
1, 2, 3, 1, 2, 3. We're online. All right, hi. Yes, so I think one of the most rewarding, one of the most developing things a programmer can do is to create games, in the sense that game dev combines the most difficult parts of the programming, because you have all of those pathfinding algorithms, all of those fancy like rendering equations and whatnot, and you have to do all of that in real time. And I would know because I have actually created a couple of games. I think all of them were created with friends together on game jams. If you like, I would encourage you to check it out later. They are PC only, so you won't be able to play on mobile, but. And yeah, does anybody know what game this is? Yeah, it's called About. It's a bit stretched for me to have played it because I was 3 years old when it came out, but I do happen to know it. I do happen to love it. And there's, in this game, if you don't know, you're tasked with programming those robots to help you navigate on the planet. And I think later you escape it. The details are a bit fuzzy, but the most important part is that you have robots and you create a firmware for them, sort of. A bit more niche game. It's called Core Wars. It's a game where you also implement bots in a bit more abstract way. And you have those bots fighting with each other. They have they expand within the RAM, simulated RAM, and they try to destroy one another. And I wanted to, for my sort of side project, I wanted to combine both ideas, so both the Colobot and Core Wars, into something more modern, so to say. And what I came up with is a game that's sort of look like a terminal. That's because, first of all, you can play it in terminal. It's online, and in a moment I'll do a quick demo. And basically in this game you have some world and those @ signs. So they are robots. Each robot has this RISC-V CPU. You've got 128 kilobytes of RAM, 64 kilohertz CPU, so they are very small by all standards. And your job is to basically program them. Right now in Rust, but in theory, as you'll see, you can program them in any language you want. And this particular screenshot is from the online mode. So in this case, all of the bots were submitted by different players, and they do all different things. The plan for today is to go, well, I will demo you the game, show you how it's played, what's fun about it. And I would like to share with you my thoughts about having been implementing it for half a year now. It's 22,000 lines of code right now because there's lots of moving parts, and I do have some thoughts about sort of post-mortem. You have some games do this post-mortems with the distinction that the game is actually still alive in development, so not really dead, but. And after the thought section, I'm hoping we'll have some time for a Q&A. So let's start with demo and see how the game is actually played. First of all, let me just start it. And basically, You connect to it. I've got a local instance because there's no internet in here, so I self-hosted it on my laptop. But usually you would actually write something like Kartoffels and you would join it. Or you can just enter it in the web browser. It works there as well. But yeah, we got it. Yeah. So like I said, this is a game where you're given a potato. And your job is to implement a firmware for it. I'll show you the online variant. I mean, it's sort of offline because it's not actually from the live game, but I copy-pasted the save file, so it's the same. So we have some bots in here. All of the bots are driven by some firmware. Let me, I don't know, focus on this one. This one doesn't print anything funny to the serial port. Oh, I think this one was submitted by a friend who wanted to do this Bad Apple movie where we have this dancing anime girl, but whatever. All right. Just saying, picked some good one. So we have a bot. This one likes to stay in the corner, apparently. We can only guess because you don't submit source code to this game. You submit only like the binary, so you can only guess by its behavior what it's doing. Oh, and it's been killed right now. And yeah, so basically we have 128 bots alive on this site within this dungeon. And they, well, the purpose of this game mode is deathmatch, so they basically trying to kill one another. And you score as much points as the bots you've killed. And in terms of how you program them, it's actually pretty straightforward. I have different demo, but yeah. So well, in this case it's Rust, but like I said, you could do it in C as well, or C++, and I'm planning to have actually tutorial for C++ later, but for now we have Rust. And yeah, so basically we have a common set of couple of operations, like motor step, which causes the bot to go one tile forward, motor turn, left, right, and there are also different kinds of peripherals. So we have this motor, but you can also use a radar to scan the surrounding area. So for instance, there's you can do by 3x3 scan, which allows you to see the surrounding tiles and then make some decisions. Like if you want to have a bot that hides in the corner, then I guess you could use like this 3x3 scan to see if someone's approaching you, and then you can run away. Basically, sky is the limit. And yeah, there are different kinds of functions as well, which I will not like to. Well, if you go in here, you can just explore all of them. There's some compass, serial, port, timer, whatever. But the basic idea is that you program them and the bots do something. And you might think that it's like not that complex thing to do. I mean, this bot, for instance, it doesn't do much. It's like step, 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 turn right. So it just works in squares. If you'd like to do a different bot, you have to program it differently. And like I said, you might think there's not much room to wiggle in here, not much to do. And I would like to prove you wrong. Yeah. Because, for instance, I've prepared a separate section related to challenges. And challenges are offline, in the sense you play there alone. And my personal favorite challenge is this personal Roomba thingy, where we are generated random maze. Not strictly maze because it has cycles, so you cannot. If you have normal maze, you can always reach the exit by sticking to the right or left wall. If there are no cycles, this is more difficult, and you have to implement a bot that navigates around this randomly generated maze, finds those 4 flags at the corners, and basically after you've found the 4th flag, you're done. That's it. And like I said, you cannot just keep to a one wall because you will run into circles. So you can think about like how you would approach this issue, because it's sort of as if you were implementing your own Roomba, in the sense that you are being put onto this map. You have nothing, I mean, we as players, we do see the map, but the bot itself, it has no awareness of the map until to the point you call this radar scan function to make it aware. And for instance, my solution for this is quite a complex firmware. I would like to just it to you. It's like got lots of comments, but basically boils down to doing some Dijkstra algorithms, some fancy stuff. And if we put it into the game, if we put it into the game, oh, snap. I do have to set up my Wi-Fi for it to compile. That's my fault because I ran cargo clean before. But no worries, it will be 10 seconds. Get it? We get it. So underneath, if you're into Rust, you might know that this /.build is not the typical way, but basically this runs cargo build release. And because I have to somehow upload it into the game, this also copies the final binary into the clipboard. And then I can, for instance, upload it. And we see that our bot is, well, in this case, my solution to this challenge. There are many. In this case, the bot is slowly learning their way around the maze. They scan the surrounding area, they tell how long it is to the nearest undiscovered tile, and they tell which way they're driving. And basically, as it walks around this maze, it sort of tries to discover the flags and then collect them all. And this is just my solution. I guess there should be like many, many more of them. And as I said, it can be quite rewarding. I think this is not like your typical Rust code in the sense that you have this sort of game dev challenge in which you have to implement a bot that you have to first figure out what you want for the bot to do, how you would even discover the surrounding area. Do you create a bot that drives towards, drives straight until it reaches a wall and then tries to change direction, or how do you do it? And this is what this game is all about. So the sort of discovery and doing cool roboty stuff. And before we move further, there is one elephant in the room that I should address. And it is that some people online have said that actually the plural for Kartoffels is Kartoffel in German. Apparently, I don't know about it. And I will stick to the version with S. And if later in the QA section you address this issue, if you ask this question or find you online questioning this choice, I will use physical violence on you, right? We'll stick into S. Yeah, so development thoughts. UI is quite difficult. I mean, we all have to deal with UI all the time, like you see it all the time. We perhaps don't use Windows XP, so we don't see this window too often, but UI is all around us. And from the point of designer, you have Figma to develop it, Photoshop, whatever is used nowadays. But from the perspective of the programmer, if you were to implement UI, there's a couple of important choices that will affect how you would like to, how you're going to code it. And one of the more important choices is between what's known as retained mode and immediate mode. And basically, if you use a UI framework that follows the retained mode philosophy, so to say, so if you use JS, for instance, or so HTML, and this is more or less how you would code it. So you have functions like create button, and then you assign event handlers to them. And after you're done with all of that, after you have the UI ready, you basically then do nothing more. The UI framework handles all of the events, calls your callbacks, whatever. And this is retained mode. For immediate mode, this sort of, and an example. So I do happen to start my learning when Object Pascal was, I wanted to say all the hype, but probably never was all the hype. Wanted to have some meetup, but I got sick and the other person didn't want to do it alone, so not that many Object Pascal fans anymore. But what was nice is that there used to be, and I think still is, Delphi, which is this IDE for creating applications, and it follows the retained mode philosophy. So you would drag and drop whatever you wanted to the form, you would assign events, and they would just be there. That's how you design the UI. For comparison, the immediate mode UI has this loop sort of reversed. So every frame, you start with clean slate, and every frame, you're supposed to tell the framework what is supposed to be on the screen. So it is obviously like just an example code, not actual Rust code, especially with the missing braces. It's like Rust and Python, but the pseudocode boils down to that every loop iteration, you start with this clean slate, you say draw button, and instead of having callbacks, frequently just this draw button or whatever happens to be it named, it returns you immediate info on whether the button was pressed, hovered by the mouse, whatever. And every frame you basically redo the whole UI. You might think that it's a bit wasteful in the sense that every frame you repaint everything, but it's actually not that bad. And one of the frameworks in C++ actually that follows this philosophy is EMGUI. So if you happen to have seen some windows like those were made using immediate mode GUI. And this is an actual example from the README. And for Rust, what I am using for my game and what I would recommend is a crate called Ratatouille. It's different from EMGUI in the sense that EMGUI, it's something that creates graphical applications, so like GUI, where G is graphic, while Ratatouille is for terminals, but it's similar in the sense that both are immediate mode. And yeah, before I show you some actual example, there's this first axis between retained and immediate mode. And the second axis is between who does the actual layout, because the issue is that it's all right, we have those, we have the call to text, the input text slider, but it's not enough to actually render them on the screen, because how do you know where to put them? You don't specify it, at least not directly, but the renderer has to know where to place them. So sometimes, as in Delphi or this example, you would probably just drag and drop them and sort of eyeball how they're supposed to be placed, but it's not always possible. This is also a screenshot from EMGUI's README, because sometimes you would like, for instance, for the UI to, as you resize the window, to follow the resize. If you shrink it, maybe the layout will have to be changed. So frequently you would want to have some layouting algorithm back in place. And yeah, if you were to choose, you have this simple issue, make the UI, and then, if you choose immediate mode with automatic layout, it will be wildly different experience between retained mode and manual layout. And I would like to show you how it looks like actually in the terms of, at least within my game. So I have a couple of nice and not nice examples. For instance, the place we are looking is, in the code, is this main menu. So it's divided into 3 components. So we have the background, we have the stop header, and the actual menu. And because Ratatouille is, in Ratatouille, you do the layout manually, all of the components have to have predefined width, which basically in this case is hard-coded. And the main function that's responsible for drawing the frame, it has to first prepare the entire layout, sort of by hand. And then you can actually, render the components after you know their placement. It can be, if you're coming from HTML, it can be a bit weird, because similar example in sort of HTML pseudocode would look like that. You wouldn't have to, from within the template file, so like this index page, you wouldn't have to worry what size is the header, because it sort of places itself automatically. The header could be any width, any height, any placement, and it sort of works out. But when you are dealing with immediate mode UI, that forces you to use sort of layouting on your own, it becomes kind of inconvenient. And it becomes especially inconvenient in places where the layout is not so easy to pre-compute. For instance, there's this page where you select which world you want to play. Like, easy, nothing special here. But it looks so ugly. And the issue is that we have this window, and its width depends on the name of the worlds. And those are not hard-coded. So what the code needs to do is first need to iterate through all of the words, check their names, add some spaces for padding, so basically those spaces around it. And only then it can actually render the window, because you cannot just say auto-size the window, because you need to know the specific width in, well, not pixels, but like characters. You need to know the specific width in order to render the window. There's no lay it out automatically. So this is inconvenient. And not to leave on a bad remark, it actually can become pretty nice at times. For instance, there is this side menu where I print, the status of the robots and serial port or whatever. And this one is actually rather straightforward. So we have like those lines that correspond to the ID on top. Ratatouille provides a lot of helpers that allow you to like just specify the foreground color, so the text color, or make it underlined, whatever. And you can pretty much see that it corresponds one-to-one to what is displayed on the this would be your right, and this is also my right, on the right side. Yeah, so user interfaces. More technical challenge. Well, all of them are technical challenges in a way, but like more typical challenge you could expect is the choice of RISC-V and WebAssembly. And to bring some context, the issue is that CPUs are so dumb. I mean, they're a marvel of engineering. They are great. But in terms of actually executing stuff, they need to have the statement sort of dumbed down. So if we have some complex expression, whatever, the CPU is not actually executed as is, and it's the role of compiler, of parser, interpreter, whatever you have, to boil it down. And WebAssembly is one of the examples that, well, it's used in web, but we'll get to that in a moment. But what's important is that it contains sort of set of primary instructions, like cons, multiply, add, whatever, that allow you to represent the more complex expressions. Like in this case, WebAssembly is a state machine, and what it means is that if we were to execute this code, we would go from the top, so we would push 20 to stack, then 30, then we multiply it to get 600, then we push 10, we add it to 610, and then we call log. And to make it less abstract, I have actually prepared a small virtual machine just to showcase it. So we have, text size. OK, you have those instructions. The virtual machine is very dumbed down, so this wouldn't be how you would actually implement WASM VM, but for the demo, it's all right. So we have the program. We have the stack of the integers, and PC, program counter, which points to which instruction are we executing right now. And let's represent the program from before. So we have those six instructions. And if we run the code, we do have 610. And the implementation is rather straightforward in terms of how complex you can get within interpreters. So when we have a const value, we push it into the stack. When we have to add some operands, we pop both of them and then push the new value. Same for multiplication. And for calling, you would actually have to implement some stack frames, yada, but for the demo, it's all right to just print it. And the issues I found when using WebAssembly, because I was actually using WebAssembly within the first version of my game and then dropped it for RISC-V. The issues is that No, I should have changed the order, but yeah. We'll get to that in a moment. So WebAssembly is actually pretty complicated. It's very memory hungry, relatively to what I'll show you in a moment. And it's difficult to constrain in the sense that, for instance, we are in here. So it's memory hungry because you actually don't have just 32-bit integers. You also have 64-bit integers. And then you have to somehow encode those within the stack. So there can't be actually, it has to be some abstract number type. That represents both of them. Maybe without the focus mode, yeah. That represents both of them, and this means that even if you push, just a 32-bit integer, it will take not 4 bytes, but actually 16, because you have to store the whole enum. And you might think that, hola, let's get smart. 64-bit integer can actually be encoded as, 2 32-bit integers. And that's what I thought initially as well, but it turns out that some of the operands, some of the instructions within WebAssembly, they are untyped. For instance, there is a opcode called select, which basically does something like this. So it pops 3 values. And then if the condition is true, then it pushes one of those values back to stack. And if not, it pushes the other. It's like your ternary operator, but not lazy, or just if. And the issue is that if you have this fancy stack without using the enums, but with fancy encoding, splitting 64-bit integers into 2 halves, then you cannot actually implement this instruction without some further pre-processing, because you don't know whether you should pop 32-bit or 64-bit integer in here. And this becomes quite problematic. There's a couple of different instructions as well. If you want to support floats, it's its own thing. And this is one of the reasons why I've given up, because, well, I only wanted for the programs to have, so the bots, to have 128 kilobytes of memory for them, because I've just got small VPS in Hetzner in Germany, and I didn't want to pay more than, I guess, like €4 for some game that's running online for free. And those small things, like using this enum, being forced to use this enum, would actually mean that lots of the RAM gets wasted, and I would either have to bump the RAM within bots to a larger value, or get fancy with the implementation. And I didn't want to. And just to wrap up on WebAssembly. It's great for what it's being made, so you can use great for what it has been made. So it's good for not direct execution, but at sort of middleman between what is delivered to you, and then you transpile it, then you compile it to some final binary. That's okay. That's how web browsers do it. But it's difficult to implement when you want to interpret WebAssembly directly, because for instance, you cannot have just a program counter. If you interpret it, if you implemented some interpreters before, this is like the go-to way to do it. But within WebAssembly, you actually have to keep the frames within in here. So if you have a program that goes 20 functions deep, so we execute a program that goes 20 functions deep, you have to keep explicitly the frame stack in here. Then each frame has its own tiny stack, and then jumping out of them is difficult. It was very messy to implement, not very performant as well. And now for comparison with RISC-V, so back, we have this as the input. Of course, bearing the fact that a compiler would just simplify it down to log 610 whatsoever, but let's imagine that it would not. For comparison, that's how it looks like in RISC-V. So first of all, the RISC-V is on the other end of the spectrum, so it's register-based. So instead of having pushes, pops, whatever, you have registers from x0 to x31. And then you have instructions like load integer, which I haven't checked if it's actually this mnemonic, but fits. So load integer, multiply, add integer, and jump. And first of all, the code is a bit shorter because in this case it's 5 instructions instead of 6, so it's always better. But it's also very, very simple to implement because what the game does is that every second basically contains of 64 ticks of the whole world. And for a single tick of the world, the game iterates through all of the bots and executes a single instruction. With RISC-V, that's very simple because, well, you basically have this index into array and execute. With WebAssembly, it was way more difficult. And yeah, that's what it boils down to. If you're into actually seeing how the implementation is implemented, there's a separate crate for that. I will not be showing it because I could talk about it for hours, and I have other cool stuff to show. But if you're into it, you can check it out. And yeah, out of the other thoughts, as I learned, TUI is actually pretty heavy in the sense that you have some, like a screenshot from my terminal, right? We have colors, we have bold text. It's bold, let's pretend it's bold, whatever. And it's all right if it's your local application that writes to your local terminal. But what I face is that when you try to transmit this data over the internet, then the metadata, so the stuff you need to, how you encode the colors, it starts to add up. And for instance, if we have a word, and we would like for the terminal to print it in bold and red, then what we would send to the terminal is actually a string like that, with the exception that those first 4 characters is actually one character. It's called escape code. It has binary code of 27, but it doesn't have any fancy characters. So for the purposes of demo, we'll just write it as esc, like escape, but it's single character. So if we wanted for the terminal to print limerence in red and bold, that's what we would send. Not bad, not bad. It's all right, it's dealable. If we wanted to have arbitrary RGB color, it gets verbose. So there's dedicated escape code 38:2. That basically means, please change the foreground color, and then you specify the foreground color. And you might think it's all right, it's doable, but if we want to have different foreground and background color, we have to send, well, in this case, like we would have white background, black text. And you might see that the actual text we want to display is a very small part of the metadata around it. So it's actually 32 characters, if I counted correctly, for the metadata, for just, is it like 9 characters of the actual word. And why it means, why it matters is that, well, a pretty UI is better than, obviously, than not pretty UI, bad UI, and I love colors, whatnot. Who doesn't love colors? I love colors. And so this comes up a lot because, like in this case, the game has to send different codes in here to change the text in here, and all of those tiny, tiny stuff, it starts to add up. And let's do some napkin math to see, because we can imagine that the average player might have terminal of size 80 by 40. If we take, on average, 10 bytes to encode a single character, including the metadata to set the color, whatever, and if we want to have 30 frames per second, which is like all right, you might have 100 to 144 hertz monitor, but 30 is good enough. And if we imagine that our game handles 64 clients, which is not much, so 64 players, connections, and let's just convert it back to megabytes, then it's actually 60 megabytes per second, or about half a gigabit, just to send those textual frames. It's a lot of data. Again, like I said, it's 10 zlotys per server. It's like stretching it to this limit. And what you can do to reduce that There's two methods. Obviously, you can compress the data. Text compresses really well, and this also affects the metadata. So like you compress the whole frame. It's all right. I do use compression, introduce the throughput by about 10 times. So from about 500 kilobytes per second when the camera is moving down to 50, which is all right. But my favorite piece of code as of recently is diffing the frames. And what it means basically is that intuitively, if we have one frame of, like the bots list, whatever, the main menu, something, and we have some new frame that we've generated right now, first of all, if the frames are identical, we don't have to actually send anything. But usually the frames differ only by a couple of characters. And there are ANSI codes, so those escape codes, that allow you to say, basically move cursor at this place and overwrite just the single piece of character line. So if the frame differs a single character somewhere, you don't have to send the whole new frame, just an instruction for the terminal to update the single character. And there is a piece of code, historical at this point, that took it to the extreme. Because this is really an optimization problem. So we have a set of opcodes, basically move cursor at, overwrite text at, or we can decide to send a whole new frame. And what we want to have is a function that takes the previous frame and the current frame, or current and the future frame, and it returns the minimal amount of opcodes or instructions for the terminal to encode this new frame. So this is exactly like a video codec works, like MP4 or whatever is the hype right now. And I'm mentioning Emacs from the 90s because it used some clever dynamic programming techniques and so on that we won't delve into here. But I love it because its code begins with this huge skull that says, beware, all ye who enter here, most of the code in this module is twisted beyond belief. If you think you understand it, you don't, so look again. And this piece of code, so this display EC, you can check out later, it contains just the algorithm for diffing between the previous and the current frame. And I think that's nice. And you might think, how have we gotten it here? Or at least that's what I thought, because I wanted to have a cool game where you program potatoes, and now I'm talking about Emacs from the 90s, right? So sometimes the historical stuff likes to come up, or I just love potatoes, wanted to have game, ended up implementing textual codecs. It happens, it's fun. It's sort of fun in the same way Dwarf Fortress is fun because losing is fun. So overall, yeah, it's nice. And if there's one takeaway I would like for you to have is to try to do stuff that I guess seems ambitious, difficult, I don't know. On the other hand, this project that didn't seem difficult at first. It just happened to be difficult, and I said, why not? Let's keep working on it. And man, I love Dwarf Fortress. Anyway, yeah. So thank you. That's my ID. So Patryk27 on GitHub. There's my website. You can access the game in here at this link. As I said, it's both terminal, but then you don't use HTTPS, just the website name. It also has web browser terminal. You can play it on your phone, so that's something for later. And I guess we move to Q&A.
Thank you very much, Patryk. Any questions to him?
Thank you for a great presentation. You mentioned a problem selecting the type of the stack for WebAssembly. But since if it is just 32-bit integer and 64-bit integer, why not select 64-bit integer, because it obviously can represent all 32-bit?
Yeah, I guess you could, but then you're still wasting half the memory if the actual binary executes just 32-bit instructions, right? So it's still some ways, but yeah, fair enough. You could always pick 64 bits. Unless you want to play with floats, in which case you will have to have some extra metadata for the type between 64-bit integer and 64-bit float. But yeah, for integers, this would be fine.
Maybe you can also fit the floats in 64 bits and just treat them, not care about the type. For select, it will work anyway.
Oh yeah, for this particular case, yeah, because we only care about the type of the for the comparison, so for the if part, but then we push back whatever was already there, so we don't have to check if it was int, and we're still pushing in because whatever was there is put back there. Yeah, yeah. For the select case, that's true.
Thank you.
Thank you for that. Anyone else?
Yeah, hi. I'm just wondering, because as I understood, the WASM was the first approach because before the RISC-V, but that seems like a strange choice, to be honest. Do you have any background behind it?
Any background behind picking RISC-V or
No. Any background behind trying to start with WASM?
So like, why have I chosen WASM at first?
Yeah.
Basically because I have played with WASM before. Like, I have had some projects in Rust that compile to WASM and run in the web browser. And using WASM was like my first idea because, well, it's new, like, right, it should be, I thought it will be straightforward. Turned out not to be so much. And yeah, basically this was sort of, I guess I know WASM, let's try it out. And then RISC-V, just to wrap up, RISC-V was chosen because I think the assembly looks cool, and it turned out to be easy to implement. So,
okay, cool, thanks. So basically, you have like had the very different experience than I had because I've tried WASM, and hell no, I would like never pick it up as my first choice after that. Thank you.
Hello, One-Tom. Thank you for your presentation. Looks a bit different than I expected, honestly. And also thanks to organizer for scheduling this presentation after lunch break. I also would like to ask, I'm surprised you if I understood correctly, you re-implemented, or can say implemented the virtual machine for
yes.
did you consider using something like QEMU? So you somebody just has to deliver some kind of binary for the particular instruction set, then QEMU on the server executes it, and
Yeah, so the issue is that I needed for this web virtual machine, so this fake CPU implementation, I needed for it to like yield after every instruction, or rather most of the implementations, or all of them, including QEMU, they work like that. So you pass to them this binary, and they sort of execute it all the time, and sometimes just ping you for like syscalls or whatever. But what I needed to do in order for the game to also be more fair is that I needed to have a function that executes just a single instruction and then gets back to me so that I can execute single instruction for the second board, third board, and so on. And the problem I had with existing Rust implementations for RISC-V, which is why I also wrote my own, besides it being a cool thing to do, was that they sort of take this control from you and they try to execute as many instructions as possible, and they don't yield back to you. So that was the problem.
Interesting, thank you.
Okay, I'll go then.
Just a quick one. You mentioned the compression. Where is it happening? Is on SSH? It's an SSH
so I have
feature
two communication channels. One is SSH, and then I'm just forcing. I can quickly show it. For SSH, I'm using the RAS SSH crate, and then I just force it to use zlib. So then if you connect to it, if your client does not support zlib, you're tough luck, toast. But most of them do, so it will work transparently. All of that had to be done. For HTTP, so when you connect through the browser, I'm using WebSockets. So there's a separate, like small HTTP server spawned. And in here, I'm just manually encoding all of the frames. And then I think it's app.js. And then on the web browser side, I'm just decoding them by calling Paco. So this is inflate too. I know, like in before, I know that there is some proposal or minor support for automatic compression within WebSockets. There's some magic header you can set, and both the server and the web browser will automatically compress and decompress the stuff for you, but it's still, like, it's not supported by Axon, so I couldn't use it, so that's why I rolled my own. And this is inflate too, and it's very CPU lightweight, so it's definitely a win. I would recommend always to try out Flate too.
Okay, so question from me. Do you handle conflicts between moves? Like
yeah, that's a very good question. I have resolved this issue by executing all of the bots sequentially. So if two bots try to move to the same location, either of them will win. Initially, this was solved by also randoming the order in which all of the bots are executed every frame, so that you wouldn't have those bots that happen to be spawned first, so they always have priority. Right now, I'm using hashmap and periodically, changing the order. So yeah, that's the conflict resolution. Just use sequentially, go through all of the bots, and the first one wins.
All right, and that's our time. Thank you very much, guys, for your questions. Thank you very much, Patryk, again.